Good morning, everyone. All right, so today we are going to be graphing exponential functions. And you're going to notice as we're doing this that it is super similar to how we graphed both absolute value functions and how we graphed radical functions. Okay, so quick refresher. Remember, our h value, that is our horizontal shift, and that tells us how far left or right we need to move. And remember, because it is subtraction in here, it's always the opposite of what we think. Our k value then, remember that is our vertical shift, so that tells us how far up or down. And then lastly, our a value, that is our multiplier, that tells us how fast this is growing or shrinking. Okay? So for exponential, again, it is super similar. Here's kind of your general formula. So notice exponential, it does have an exponent in it. So as always, that h value tells us left or right, opposite of what we think. Our k value, as always, tells us up or down, that vertical shift. Our a value is always our multiplier. It tells us how fast we're growing or we're shrinking. And you're going to notice this new thing in here. This is the b value. The b value is our base. And I'm going to show you two examples. We'll talk about the base a little bit more here, and you're going to see how the base affects our graph. All right, so let's go ahead and get started. Let's do our first one. I'm going to rewrite that equation. There we go. So notice in this one has an a value of 1. So it's just kind of growing at the normal rate here. Okay. All right. So first thing we are going to do, like always, is we are going to figure out our shifts. So remember, the number with the x is our h value, and that tells us our horizontal shift, opposite of what we think. So this is telling me I need to go left 3. And then my k value, my vertical shift, that, like always, is telling me I need to go up 1. So starting on my graph, I'm going to go left 3, up 1, and I'm going to make an X there. Now, that X is not actually part of our graph. We are going to treat that X as our new origin. Okay. So now let's go ahead and take a look at what we haven't done anything with. So we haven't touched our base yet. We haven't done anything with the 2, and we haven't done anything with the X yet. So we've taken care of our horizontal and our vertical shift, but we haven't touched that 2 to the x. So now, like always, we're going to make our table of values. And remember when we were doing the radicals, the square root, we had to pick nice square root numbers for x. We chose like 1, 4, 9, because we could perfectly take the square root of those. Today, we don't have to worry about that. We can plug any number in for x and it's going to turn out nicely. So I am going to just plug in the basic 5 for x. I'm going to plug in -2 to +2. So now let's go ahead and plug that in for x. So I'm going to end up with 2 to the -2. Remember, when we have negative exponents, that flips it to the bottom. Oops, helps if I actually do that, right? And notice our exponent becomes positive. And now when I clean this up, 2 squared is going to be 4. So it's going to be 1/4. Same thing, I'm going to go ahead and plug in my -1. It's going to flip it to the bottom, and 2 to the -1 is really another way to write 1/2. Keep on it going. Anything to the power of 0 is just 1. 2 to the first is just 2. And 2 squared is 4. All right. So now, just like always, remember our x piece tells us how far left or right we need to go. And then the y piece tells us how far up or down. So if I look at this first point, starting from my x, remember that is kind of our new origin. Starting from the x we made, we are going to go left 2 because this is negative, and then up 1/4 because that's positive. Okay. Next one, starting from our new origin, from our x, this one's saying we need to go left 1, up 1/2. This one, we're not going left or right at all, but we needed to go up 1. So not going left or right at all, but up 1. This one's positive, so this time we're going to move to the right and up. So from our new origin, we're going to go right 1, up 2. And last one, this is saying we need to go right 2, up 4. So 1, 2, 1, 2, 3, 4. So you can kind of see we're very, very quickly growing. We have exponential growth right there. Exponential growth. All right. So I want you guys to think about, because obviously we have these 5 points, but obviously it extends past those 5 points. I could plug in more numbers for x than the basic 5. So if you think about it, what happens when I plug in -3? What happens when I plug in -4? And hopefully you're realizing that that y value would get smaller and smaller and smaller. But it's never going to become negative, so we never would move down. And over here, it's going to grow really, really quickly. All right. So again, you're noticing that it is never, ever going to cross this line right here. It's going to get closer and closer and closer and closer and closer and closer and closer to it. But again, 2 to the anything will never give us a negative number. So it's never going to cross that line. So this line we call right there, we call that an asymptote. So it's kind of like an imaginary boundary line that this graph is never going to cross. Asymptote. All right, so let's look at our domain and our range. Remember, domain is our x values. So if I look at my x values, keep in mind this graph is going on forever and ever. Our x values, it is going on forever, so we will hit all of the negative x values. And again, it's growing forever as well. So eventually it's going to keep going over and over and over and over, which means we will hit all of the positive x values as well. So our domain will be all reals. Our y values, though, notice we have no graph down here whatsoever. The lowest y value that we will have is that our asymptote is at 1. And we want the y values that are greater than 1, that are bigger than 1. But again, it can never be 1 because of that asymptote. It's never ever going to touch it. So it won't be an or equal to. It'll just be a y is greater than 1. All right. And I said I wanted to talk about this exponential growth. The reason it is exponential growth is because our base is a whole number, I'm going to say. So exponential growth, it gets really big really quick when we have a whole number right there. Okay. We're going to see in this next example, notice our base is a fraction. We are going to see exponential decay. Exponential decay, which means it's going to get really small really quickly. And again, exponential decay happens when we have a fraction there. All right, let's go ahead and graph this bad boy. So notice we have a multiplier this time. We have a multiplier of 3. But we're still going to graph it the same way. So remember, the number here is our horizontal shift, opposite of what we think. So this means that we are going to be shifting to the right one. And then our k value, our vertical shift, that means we're going to be shifting down 2. So from my origin, I'm going to go right 1, down 2, and make my x. That will be my new origin. All right, now let's take a look at what we haven't done anything with yet. So we haven't touched our multiplier of 3. We haven't touched our base. And we haven't touched that x exponent either. And now again, I'm just going to plug in my basic 5 for x. And I'm going to go ahead and plug those into our equation here for x. All right. Okay. I'm going to need some stretch paper. I'm running out of room. So remember, if we think of PEMDAS, we need to do exponents first. So if I go ahead and clean up 1/2 to the negative 2, we know the negative is going to flip this. So it's going to become positive 2 to the power of 2. Or if you want to think of it this way, it's technically getting distributed to both of those. So both of them would flip. But 1 squared is just 1. Okay, so this is going to become positive 4. But remember, we have to times that by 3. So 4 times 3 is going to give us 12. All right, let's go ahead and do the next one. So if I go ahead and plug that in for x, I need to take care of this first. Technically, that negative 1 is going to both of those. And we know negative exponents flip. So this is going to flip to the bottom. And this is going to flip to the top. And remember, 2 to the power of 1 is just 2. So 1/2 to the negative 1 is just 2. Don't forget, we have to multiply that by 3, though, which is going to give us a 6. Let's go ahead and plug in 0. So we know anything to the power of 0 is just 1. 3 times 1 is 3. Let's plug in a 1. So 1/2 to the power of 1 is just 1/2. Times it by 3, you're going to get 3/2, which is 1.5. All right, last one. Let's go ahead and run another room here. Let's go ahead and plug in 2 for x. So if I distribute this 2 to top and bottom, it's going to give me 1/4 times that by 3, and I'm going to get 3/4 or 0.75. All right. So now let's go ahead and graph this. So my x value, that's saying I need to go left 2 because it's negative from my new origin, and then up 12. This one is saying I need to go left 1, up 6. I'm not going left or right at all, but I need to go up 3. I need to go right 1 because it's positive, and up 1.5, and then right 2, up 0.75. So you can see, like I said, we have exponential decay. It is getting really small really, really quickly. And again, we are going to have an asymptote. So as we plug in more values for x, this number is going to keep getting smaller and smaller and smaller and smaller and smaller. But that number is never ever going to cross the line y equals -2. We have an asymptote there. All right, so now again, domain and range. So our domain, again, this is going on forever and ever in both directions. So eventually every single x value will be hit. So our domain is all reals. Our y values, however, again, notice we have nothing down here for our y values. Our lowest y value that we will have is -2. And we want the values that are greater than that. But remember, it's never going to actually be -2 because of that asymptote. It will never, ever, ever cross that line or touch it. It's just going to get really, really close to it. All right. One other thing before I let you go, I want you to think about what happens when we have a negative a value. And just like all the other things, that would make it flip upside down. It would be a reflection. So in this case, it would look something like this. So negative a values do the same thing they always have. All right, there is graphing exponentials.